Order of operations is a topic that a lot of folks struggle with. Most of the time we learn it as parentheses, exponents, multiplication, division, addition, subtraction, or a regional variant that means the same thing. But that often leads to confusion, as it doesn't clearly indicate what order you should tackle multiplication versus division, or addition versus subtraction. On top of that, it leaves off a lot of information that would otherwise make correct calculation much more straightforward. So let's take a different approach. Let's relabel this as grouping symbols, exponents, multiplication, subtraction. Wait, what happened to division and addition? As it turns out, we can think of addition and subtraction as sort of the same. Likewise, multiplication and division are just two sides of the same operation. Of course, even if we do adjust the way we think about all of this, we still need some surefire way to guarantee that we do things in the correct order. Put in simpler terms, we need direction to go with our order. So let's go piece by piece. Grouping symbols. When we say grouping symbols, we're talking about a lot of different things. Parentheses, brackets, braces, radicals, fractions, functions, absolute values, and a whole host of others. How do we deal with these? What's the mathematics we do for grouping symbols? We separate them from our work and treat them like an independent entity, performing the order of operations on that before we move it back to our initial setup. We notice if we look to any depth at all that grouping symbols can have grouping symbols inside of them. So how do we handle this issue? Since we take care of grouping symbols first in our order of operations, and since we treat each appearance of grouping symbols as an independent entity, we see that we will be diving into the deepest grouping symbols before we do anything else. So, for our first step of order of operations, we have grouping symbols from inside to outside. Exponents. Exponents can be viewed as repeated multiplication. We handle these next. Evaluate them just using whatever is the appropriate method. But what happens when we run into something with a funky exponent, like this? Turns out that the exponent itself counts as a grouping symbol, while the evaluation of the exponent is separate. So really, we look at the exponent and do order of operations on it, which means to clear grouping symbols first. So we keep working our way up and up and up until it can be evaluated directly. Perfect. So now we have a consistent scheme to deal with exponents. Simple exponents just get evaluated, but complicated exponents are handled via order of operations, meaning we work from the top down. Then our second step in the order of operations is exponents from top to bottom. Multiplication. Before we even get started, let's deal with something I said a while ago. Division and multiplication are two sides of the same operation. But what does that mean? When we see something like 5 times 3, it's like saying, make 5 groups of 3 things. When we see something like 15 divided by 5, it's like saying, put 15 things into 5 groups. So we can think of both as grouping operations. So what? How does that make the connection we need? Fractions are the linking piece here. Dividing by a number is the same as multiplying by 1 over that number. The place this is most obvious is multiplying and dividing fractions. Think about the rule keep, change, flip, which puts this into practice. Great. So we have the link between multiplication and division, but what order do we do them in? By convention, we work from the left when everything is equivalent. So we'll handle all multiplication and division at this point in that way, and division will just be treated as multiplication by 1 over anytime we're unsure of what to do. That gives us our third step, multiplication from left to right. Subtraction. It's a bit more obvious that addition and subtraction are the same, since we can treat them both as just counting up or counting down by a given amount. Where addition counts up, subtraction counts down, and vice versa. But how do we deal with this in order of operations land? We can either ignore it and just handle them regularly, which is optimal, or we can replace every occurrence of one with the equivalent form of the other, which is risky even on the best days. Just like with multiplication, we see a bit of a problem. What order do we do them in? Again, by convention, if things are equivalent, we work from the left. So we'll do that now. Now here's something pretty fun. If we do replace, for example, all appearances of subtraction with plus negative, we can rearrange the work into any order we like, which is an important skill when we start doing fun things in algebra. But we're going to hang on to this for now, since it's not super relevant. With that, we have the final step, subtraction from left to right. So, our order of operations is grouping symbols, exponents, multiplication, subtraction, with the appropriate direction for each. This is easily remembered with the initialism GEMS, which serves as a quick mnemonic device that's easy to both teach and learn. Let's see this in action in this truly ugly example. And there you have it. Thanks for watching. Good luck out there.